How do you operate this at scale across many distributed locations? In almost every enterprise that we work with, they have many sites with different sizes and complexity, right? These sites, for example, there may be some small processing facility with just a handful of people at that site. There may be large manufacturing plants with hundreds of workers and complex automation environments, or there may be storage locations, yards, distribution centers spread across US or even globally. So what these sites often have in common is limited local IT and OT expertise. You can't assume that every location has skilled network engineers available to design, configure, troubleshoot a cellular network. And from a cost perspective, you don't want to build a model that depends on flying experts on every site whenever something happens on that particular location. At the same time, from an enterprise perspective, these sites still need to be managed consistently across the security policies that needs to be enforced. Performance expectations need to be maintained in a predictable manner, and the visibility needs to be centralized. So the challenge isn't just deploying private 5G at one site, it's operating a private 5G as a distributed system across sites at very different sizes, maturity levels, and using a common framework. This is the lens through which we designed our operational model. The goal is to make private 5G that can be deployed locally but managed centrally, right, without requiring a deep cellular expertise at every site. So to address this challenge, across many sites, we designed the system around a lightweight deployment model, and we call this as Celona Airflex. The key architectural principle is to centralize what makes sense and localize what must stay local. So the control plane for configuration, policy, lifecycle management, and visibility is handled centrally through the Celona orchestrator, and this gives you a single place to define the policies, manage devices, monitor the health across all sites, but at the same time, the user plane, the data, stays local. This means that the data traffic does not need to be hairpinned across, going to a central location or going to cloud. Instead, applications continue to run locally, the traffic stays local, latency stays very low, and the site remains operational even if the connectivity to the control plane is temporarily disrupted on the backhaul. So this means in practice that a small or remote site can be extremely simple to deploy. For these sites, you only need to install maybe 1 or 2 radios, nothing else, no other appliance. And those radios, APs, can connect directly to the existing switch or router and you will be done. So you don't need to deploy a full on-site core or dedicated edge infrastructure for any of those locations. And from an operational point of view, this is critical. Many of these sites don't have an on-site IT or OT staff. Everything from configuration to software upgrades and performance monitoring can be managed centrally through the orchestrator. Local personnel can be involved in only very basic tasks, right? Such as mounting the hardware, enabling the devices, maybe putting the SIM cards in certain devices if eSIM is not enabled on those devices, but they don't need to understand cellular networking or security policies. And this results in a deployment model that can truly scale. And you can start with a single site, expand to dozens and hundreds, and we have great examples of this across different verticals with our existing customers.